right, I think I gave all of them the rights to speak. If you can confirm, guys, Andrea, Andrew, Peter,
Yeah.
if it's working.
Yeah, it's working.
Testing, testing.
Perfect.
Testing.
All right, good. All set, I guess. So, yeah, guys, let's wait one more minute for people to tune in, and we will kick off then.
Sounds good.
Sure.
Looks like we've got quite a few people listening already. That's great. I think this may already be one of our biggest looking X spaces, so it's a good sign.
It looks like that, yeah, right. Very, very cool. Thank you, everybody, for joining, obviously. It's going to be an exciting AMA, lots of stuff to talk about. So, I mean, maybe I can just ask a simple question. How are you guys? Everybody, how are you doing? Everybody good?
I'm doing great, yes. Looking forward to this conversation.
Same here.
Awesome.
Yeah,
Awesome,
doing
very good.
great. Thanks, Martin.
Well, thank you guys for your time, first of all. I mean, I know everybody's very busy, so a lot of different time zones as well. So it's quite a kind of challenge to get everybody on the call at the same time. But we made it, which is awesome. So yeah, guys, let's kick off. Like Paul said, it's already quite a big audience, which is awesome. I mean, everybody noticed lately that we had quite an inflow of new community members. So I think it's wise to give a small introduction about everybody that's on call right now, for all the new joiners to have an idea about the background and what they are doing within Nexa. Yeah, just briefly about everybody. So we have Peter Rizun on call here. Peter is our scaling scientist, so to say. So basically, what he's doing on the background is creating hardware that make Nexa scale for global adoption. On the side of that, we have Andrew Stoner, obviously. It's our lead developer, who's basically responsible for everything within the blockchain from A to Z. Kind of some of our community members joking about it that Andrew is the teacher of all the blockchain students. So there's that. On the side of that, we have Paul Church. Paul is the head of communications within Nexa and Bitcoin Unlimited. He's also the founder of Otoplo, which is basically laying the fundament of infrastructure on Nexa. Many of you obviously are using the wallets, Otoplo wallet, the Tokenize tool, and similar things. And then we have Andrea, which is who is the core developer of Nexa. Various responsibilities, I would say, from coding to nodes to everything related to the Explorer to helping me with new partnerships and exchange integrations and things like that. So yeah, there's that, guys. I think I mean let's start with a very basic question. A lot of community members are obviously excited to know what you guys are doing right now. What is the main let's say point what you are working on now? So maybe we can just do a simple round one by one, asking each of you what the core focus for you is right now. So I'm not sure who wants to kick off, but feel free to team in.
Sure, I'll kick off.
Yeah.
Yeah. So I am working with our Sheni on our FPGA scaling activities. So what we're focused on right now is the hardware on the FPGA to do the Schnorr signature verifications. So our Sheni and I have been working on that, and at the same time we're implementing a very simple stack machine within the FPGA, which will eventually run the full script verification, similar to the virtual stack machine that's used in the Nexa code. So
Right.
yeah, we made great progress on that, and we're hoping to release something to the public. I think it'll probably be January, but we'll see. We still got a bit more bugs to work out.
Right. That sounds cool. And Peter, maybe you can highlight a little bit, because there is quite a few new people here. What is the exact thing that you're doing with the FPGAs? Why are you mentioning this?
Okay, sure. So my interest is scaling Nexa to global levels. So I'm thinking, hundreds of thousands of transactions per second, a blockchain with 10 billion UTXOs, and I think we can get there leveraging technology that already exists. And the awesome technology that exists are these things called FPGAs, which are field programmable gate arrays. So they basically allow you to. So instead of writing software for a computer, on an FPGA, you describe a circuit and then it's synthesized in the FPGA itself. So with that technology, we can turn the fabric of an FPGA into specialized hardware circuits that are just right for solving the scaling bottlenecks in Nexa. For
Right.
example, doing the Schnorr signature verification on a normal, in Bitcoin Core, that's done in software using the computer's processor and the ALU within the processor, but it's limited. There's only a certain amount of transistors that could ever be dedicated to that process of doing the signature verification. On an FPGA, we can take millions of transistors and wire them in a way that's optimized for solving that specific signature verification problem. So we're able to do that much faster and more power and transistor efficiently.
Right. Okay, cool. Thank you, Peter, for the explanation. Later on, we will team in a little bit more on the scalability side, if you're okay with that.
Can I chime in there for a second?
Sorry?
Yes, please.
I'd just like to add to our listeners that, of course, the final end goal is to have like a little plug-in board that can be placed in maybe the M2 slot or USB slot of any computer that will do these calculations. So it's not like because we're doing custom hardware that therefore means that you need some specialized machine. It just will plug right into a standard computer.
Yeah,
right.
That's a great point. Thank you, Andrew.
Yep.
Right, that's a good addition. Yeah, definitely. Thank you, Andrew. Well, Andrew, since you're speaking, maybe you can give a heads up what you're on lately.
Sure. So first of all, we are finalizing a full node release that will be coming out in the next week or two, and that will mostly focus on some new features around tokens for the full node. So the full node will have caught up with other wallets in terms of supporting and showing the tokens, and other like NFTs and stuff like that you happen to be holding. And then also in my own work, I'm working on making a single wallet scale using our Kotlin-based libraries. And the purpose of this is to support so it's needed. It might as well be put into your standard phone wallet because why not? It'll just make things more efficient. But the real purpose is for people to deploy, exchange type wallets that may need to have, ultimately, 100,000 transactions per year or something like that, in one wallet, right? And what's fun about this is it touches a little bit on scaling because obviously I'm not waiting around for a year to make this happen. So I've been, punching out in the last few weeks a whole bunch of transactions to make my tests happen in a few hours. And it's fun to watch actually our full node barely even register on the CPU use. Statistics in my computer. So that's kind of good news.
Right. I think you also shined a light on that in the Telegram group recently, right? If I'm not mistaken.
Yep. I've been posting on Telegram about that just to kind of keep people in Telegram aware of, what's going on in development on a weekly basis, just so that they can not feel like development is not happening and then all of a sudden, boom, a big drop happens, right?
Right. No, it's much appreciated. Yeah. We got a lot of positive feedback about it too, so that's cool.
Okay, great.
All right. Thank you, Andrew. I'll get back to you later with some other questions. Perhaps, Paul, you you want to shine a light on what you're doing lately?
Sure. So, kind of the main two areas of focus have been and are going to continue to be Tokenize and Nexscript. I mean, I'm doing some other things as well, but like they're probably the two things I think people will find most interesting right now. Tokenize. So both Tokenize and Nexscript just got BUIPs approved by Bitcoin Unlimited, which is great. So.
Right.
Although we've already kind of gone ahead and started working on some of those things, it means that now, that work is going to be locked in. So that's going to cover the next kind of maybe 3 to 6 months of work on expanding those. So if I first talk about Tokenize, so if you don't know what that is yet, Tokenize is a tool for launching tokens on Nexa without requiring any kind of like programming knowledge or kind of any knowledge at all. Really, it's like super simple user interface. Where it's like a desktop app. You can go in there, launch a token at basically zero costs, like a minimal amount of fees. You can set the metadata, you can send, receive them, control different properties about them. So that's a good starting point. And so if people want to launch projects, token projects on Nexa, they can do that right now very easily. But the next phase of it is to start making it easier, much easier to add specific properties to tokens, properties that you often see on, let's say some ERC20 token projects on Ethereum. We can do the same thing on Nexa using smart contracts as well. But if maybe you're not a developer, or you don't want to spend the time to get more into the core technology, then we want to be able to provide options for people that they can still get those kind of advanced functionality into their token project. So that's what the kind of next stage of Tokenize will be about. Like if I give some examples, like you'll be able to time lock emissions. So instead of just creating tokens and then manually minting new ones or manually burning tokens, you'll be able to set up front like an emission schedule, and because it will be locked by smart contract and very easy to verify, any of your investors or anyone who has an interest in those tokens will then be able to see, this is the emission schedule. They can't have more tokens than this at this point in time. Same as like Nexa emission schedule, right? And then like token vesting, so you could set an emission schedule, but for tokens that go to a specific person's address. Reward pot, which is a term I came up for something similar to like dividends, but without the issue of dividends where you'd have to send very large number of transactions out to tons of different addresses. You could do that very easily on the network, but there's a better way of doing it, which basically puts funds into a pot or a pool and then allows people to take out from that pool whenever they want. And then airdrop, obviously, I think everyone at this point in cryptocurrency knows what an airdrop is. And then like hosting for metadata, because right now on Tokenize you basically have to go either host it yourself, or we've given like a very easy option, like recommended option. We want to be able to make it super easy and actually provide an option for hosting with us, and then a bunch of other stuff. So you kind of get the point. That it's like the goal is to make easier to offer more advanced token projects. And then another function we want to add to it is voting, because we've I personally feel tokens are one of the easiest ways to create voting systems, like verifiable on-chain voting systems. So we want to add that, a user interface for doing that. You could already do it right now, right? So you could just launch a token, like mint a bunch of tokens, give them out to a group of people, community, for example, and then create, let's say, 2 addresses, and then that community could just choose their sending tokens to another address. So you could do that right now. We want to put like a nice user interface for a functionality like that. And then if we can kind of fit it within the budget, then we're going to also try and offer launch functionality within the app. So this is one of the benefits of having an application that we are not hosting, right? So we just put the software out there. It's fully open source. It gets downloaded, and because we're not actually, it's not hosted on a website, and it's not, we don't manage it at all. We don't have to worry about the regulatory side of things, of actually like crowdfunding or crowdfunding token launches. That just gets individually handled by the projects that want to use the software. So yeah, crowdfunding token launch is one of the functionalities we want to add, which we think will make it much easier to launch a project and launch it with some money if you can convince people to do so. So that's
Sounds
the
very cool.
Tokenize side of things. So yeah, like I said, that's kind of going to cover the next 3 to 6 months worth of work. And we think that will offer some really useful stuff to people that want to come and build on Nexa and reduce the barriers to them to do that.
Right.
And then
Well, I think it's
on the other,
a significant. I think it's a significant improvement because, I mean, obviously right now everybody can launch a token right on top of Nexa, but having these possibilities within there, people or a project leader can actually launch a project with an ICO included or a pre-sales and everything like that, right? Given
right, I mean,
potential of having release schedules and stuff like that.
yeah, exactly. I mean, I think even if you did have like developers on your team, which many projects will likely have anyway, it's still beneficial to
Right.
save that time and money, right? So, rather than having to code everything up from scratch, it's nice to just be able to have like a system already in place to do that. So that's why we're taking a bunch of the properties that already are common within kind of the token space, and then putting them into the software. So yeah, so that's Tokenize, and then what kind of ties into that as well is Nexscript. So we're also trying to take Nexscript further. So again, for people that don't know what Nexscript is, Nexscript is a smart contract programming language on Nexa and an SDK for deploying and managing those contracts on chain, and essentially what it does is just makes it easier to implement smart contracts on Nexa, because if you didn't use this, you'd have to do it purely in script, which is obviously completely doable. That's how we did our first smart contracts at Toplo. But as soon as you start getting into more complex contracts, it becomes very difficult to manage, especially when you're talking about large covenant contracts, or what we call I've forgotten actually a term now, but basically complex contracts which have like multiple stages, multiple different UTXOs, like all interacting. It gets very difficult to manage purely in script. So Nexscript makes this much easier, the same way that Solidity on Ethereum does. So. And it's quite similar to Solidity as well. So we're also making it easier for developers that already are familiar with Solidity to come over to Nexscript and start building on the Nexa network. So we're basically expanding that. We're trying to also offer proposals at the consensus level for some opcodes that we think would basically make things like contract implementation more efficient, and open up some new possibilities there. And then also expanding actually Nexscript and what it can do. So we've already taken it quite a long way in terms of the level of complexity of contract that you can write in Nexscript, but we want to go further than that. So yeah, that's what the BYP covers. My personal favorite, let's say, of the features we've been working on recently is op Merkle, or a way to validate various accesses to a Merkle tree within scripts. And that's because if it does get implemented, then it will allow smart contracts on Nexa to fully manage off-chain storage of basically arbitrary size. So right now, if you have storage on a smart contract on Nexa, it has to kind of be stored in the UTXOs, which is doable. But as soon as you start getting, let's say, 100,000 addresses for like a token whitelist or something like that, it would be
Quite
very, very
significant.
difficult to implement. Yeah, exactly.
Right. Yeah. Right.
So instead of doing that, you could use this op Merkle technology, which would basically allow you to contracts to arbitrarily access both validate a read, write, or append to a Merkle tree with a simple opcode, and obviously that will get implemented into the Nexscript language as well. So but there's a bunch of different stuff we've been working on. So we just want to make it as useful as possible and as easy as possible to come build really interesting DeFi applications on Nexa.
All right, that's the goal. Maybe we can. I'm actually thinking right now. Can have a short AMA separately about the whole functionality and possibilities within Nexscript to give a bit more on information and details on the technical side of it. I think it's a good thing to set up at some
definitely.
point.
I think actually, I definitely think that people have not quite understood how much capability there already is right now in Nexscript, because you can already write contracts that have like of almost equivalent complexity as an EVM right now. Like not the same, we're not quite at that level yet, but you can really take it a long way already with what we've implemented over the last kind of only three or 4 months. So yeah.
Right. Yeah, cool. So let's do that. So thank you for now, Paul. The last one, Andrea, maybe you can share a bit about what you're doing lately and what you're up to.
Sure. Hi, everybody. Thanks for having me in the first place. So,
very welcome.
Thank you again. So what I'm doing right now, I'm just finished to deploy initial version of the changes needed for the Explorer, Nexa Explorer, to be aware of token, so that now token creation, melting, minting, transferring of the token could be displayed on the Explorer. So if you are looking at a given transaction that is transferring NFT from one person to another, or tokens for different purposes, you can have access to the actual information. This is almost a prototype, because we need more things to get it complete, but is it a first good base to build upon? Then the other thing that I'm doing right now, let's say that can be summarized in strengthening the release process and then of the actual Nexscript and the CI, the continuous integration, which is the tool that we use to make sure that all the changes that we made to the code are actually good and are not introducing more bugs than they are supposed to do. So for example, right now we are perfecting the process to release the Nexscript, adding a new ARM architecture for macOS, which is the new CPU processor, the M1, M2. We are adding deterministic binary executables for Nexscript. Along next to it, we are going to sign those new binaries with certificates so that people could run flawlessly the binaries on new version of macOS without work around all the warning and stuff like that every time you download a software from the internet, right. So then other thing that I'm going to do, which is on my to-do list, is to set up a node counter for Nexscript node that display public nodes and categorize them by geographical area, version of the software, kind of connectivity, stuff like that. Yeah, and another thing that I'm working on right now is improving documentation of the actual RPC layer of the Nexscript daemon node, so that people could have access to the documentation through the website, GitLab repository in a HTML form, or maybe Markdown, something like that, so that people and Exchange that want to integrate Nexa could look at it. Just like we have for our rostrum election implementation, so that, if third parties are interested in integrating Nexa on their product, they could, just look at it and basically decide and estimate how much work they would need to do that.
Right.
And then there are minor things like code cleaning and stuff like that on the node side. But yeah, this is basically what I'm working on right now.
Awesome. Thank you, Andrea, for the update.
You're welcome.
So yeah, for everybody, I think the main takeaway of everything that you heard so far is that whatever we are building within Nexa it has to be easy to digest, right? So when it comes from the Tokenize app or the scaling via hardware or the integration documentation, what Andrea just talked about, everything what we are trying to deliver has to be sort of plug and play as we can call it, right? So I think that's a great thing moving forward for either developers, for community members, or everybody that wants to interact with Nexa. So yeah, thank you guys for the sum up about what you guys are doing right now. I think it's a good moment to jump into the community questions that we received either on Telegram or on Twitter. And there was one question actually that I believe that it has two that is worth two different explanations, so to say. And I think one is the best to explain from Peter Rizun, and perhaps Andrew can take it from the other side. So the question is, what is the technical differences and improvements between Bitcoin and Nexa when it comes to either scalability and when it comes to programmability? And I'm guessing the scalability is a good one for Peter to start with, and shortly after, Andrew, if you could shine a light on the programmability side of it, I would appreciate it.
Okay, I'm not sure you're going to like my answer, but my answer is nothing.
It's nothing. All right.
Okay, but let me explain that. What I mean by that is, I think everybody, all the Nexa developers, came to Nexa because they believed that Satoshi's original protocol could scale to a global P2P cash system. And there was nothing wrong with the protocol. It's UTXO based, unlike Ethereum that has all the global state problems. But what was limiting Bitcoin was just the lack of implementations that could scale and the stupid block size limit. So I think one of the things I think I'm most excited about Nexa is the way we did our proof of work. So we said there are no real fundamental scaling limits for a Satoshi-like protocol. People just have to do the hard work. So we made the mining algorithm. So in order to be good at mining, you have to be good at solving the scalability bottlenecks. And the first thing that we're doing on mining is the signature. The elliptic curve point multiplication, which is an important part of signature verification, and the hash rate of Nexa has just soared because all these innovative people, they found ways to leverage GPUs, and now they're doing like 10 million elliptic curve point multiplications per second, which equates to like 1 million transaction verifications per second on a GPU. Something that 3 years ago Bitcoin Core would have said, that's impossible. You just can't do that many signature verifications per second. We said, no, it is possible. People just have to be incentivized to actually make it work. And I think that's something we've already proven. I don't think that's got enough publicity either. Like how cool the proof of work is and what we've already shown how it can help scaling.
Right. I mean, maybe you can, because once again, there is a lot of new guys here. Maybe you can shine a light on the fact that actually Bitcoin Unlimited has been trying to implement this on Bitcoin itself. Maybe you can shine a light on that.
You mean like with the block size wars?
Yes.
Yeah. So I guess like everybody in Nexa came from Bitcoin. We were all, I guess, OGs in Bitcoin. I think most of us have been around since 2013 or earlier. But yeah, we all believed or bought into the Satoshi white paper that, and remember Satoshi's statement that Bitcoin never really hits a scale ceiling, and I think everybody in Nexa to really believe that. And when we started bumping up against the block size limit in 2015, all of us were fighting really hard. We created Bitcoin Unlimited, which was a new implementation of the protocol.
Right.
To show that we could scale beyond 1 megabyte and way beyond. The Nexa team, we did these 1 gigabyte block tests, and we presented that at Stanford at the Scaling Bitcoin conference, where we showed that with some changes Andrew Stone made to the Bitcoin full node source, that we could propagate and process these 1 gigabyte blocks every 10 minutes. So our team has been really pushing hard for bringing peer-to-peer cash to the world via the Satoshi protocol, and we just weren't getting anywhere with Bitcoin. So Nexa is what we've done, so we can kind of prove some of our ideas in the real world.
Right. Thank you for that,
The
Peter.
key thing, could I jump in for a second?
Yeah, absolutely, Andrew.
Right. So the key thing about doing it within the UTXO style that Satoshi presented is to not lose certain key features that exist, right? And so
Right.
I think you'll find, if you look at other blockchains, you will discover, if you really dig into them, you will discover that certain features are lost. In particular, SPV proofs. Now, and that is kind of a given. Now, what is under debate is whether those features are valuable or not, right? I believe that they are very valuable, and they without them, the security model is eroded. But you can, of course, make an argument that, oh well, like Bitcoin has been making with Lightning and their efforts. Oh, well, this is okay. This change security model is fine, right? But I think that it's whether that's true or not. It's disingenuous to not describe the security model changes when you claim a high scalability number. And I think with a lot of altcoins, you may find, if you look under the covers, that that's what is actually happening.
Right, that makes sense. And when it comes to programmability itself, can you explain the difference between Bitcoin and Nexa?
Are you talking about getting into sort of the feature stuff?
Exactly, yeah. Tokens,
yeah.
smart contracts, and
right.
stuff like that.
Yeah, so there's a huge number of changes. And, the white paper that's coming out will more focus on that, right? And the thing is that we did not lay upon Nexa like a single feature, right? It was not created because we had one idea, right? What we're trying to do is take the best of many different ideas and pack them in. And so in particular, we're considering, the creation of a blockchain that is optimized for finance and optimized for exchange. And if you look at Bitcoin, it is more optimized for transfer. And this is a weird idea, right? But the very fact that Bitcoin does not easily have tokens means that there's one noun in the system, Bitcoin, right? And lately there's this inscription thing, and I don't want to get into all the problems with it, but there are some. But with Nexa, the first and probably largest user visible change is the group token system. And so that allows you in the Nexa blockchain to basically natively see tokens, NFTs, SFTs, which I kind of made up that term, but semi-fungible tokens, right? If you made 50 of a particular item and you give out, like everything people call NFTs, many things are actually SFTs, right? Like a baseball card, sure, they printed, 1,000 of them and there's 100 left in the world, right? So it's not technically a unique item, it's just almost unique.
Right.
So SFTs would be semi-fungible tokens, right? And then So group tokens allows a lot of cool stuff around that. Of course, it also would allow you to put stable coins and things like that onto the blockchain. And then something a little bit weird that people hasn't seen much light of day, but I think it very much will, is this idea of fencing other Nexa. And so what that is you can say, oh, there's a reason why I called my protocol group tokens, not just tokens. And that's because you can create groups of stuff. And one of the, the thing that you can create a group of is Nexa. And so that would mean that a smart contract that you've applied to the group applies to the Nexa that it contains, not just to like a token. Why is this important? Well, the biggest reason is so you can have like on-chain backing of something else, right? Because you could basically create a group that holds Nexa and you fence the Nexa into the group and you say, no, you can't withdraw Nexa from this group unless you're following certain rules in the smart contract, right?
Right.
And so, so that's group tokens. Then we have this system called template scripts. And what it basically does is it, first of all, it pushes all the data possible into the inputs, not the outputs of a transaction, which may seem, this is a little unintuitive, but what it basically does is it loads the data into an area where it can be like used and then thrown away instead of having to be stored in the UTXO set for a long time. So that is a big feature. And it also allows three-party interactions instead of two-party. And the three parties would be the entity who created like the overarching smart contract, and then potentially like a holder and a buyer, right? You see how there's, like in standard Bitcoin, there's two parties. There's the receiver and the sender, right? But really, in sort of a smart contract world, you need three parties. You need the person who's sort of enforcing the playing field, right? And then you need the two participants, a minimum two participants in interaction. So template scripts allows you to do that. And then we have a host of smaller features like SIG hash improvements and new opcodes and stuff like that. But I think that's a little bit too low level to really go over. And then I want to say one more thing sort of on the lines of what Peter R. was saying about scalability is it's key that we preserved the UTXO architecture and also the limited, while we've expanded like the opcodes and things that you can use dramatically greater than that of Bitcoin, it's still limited in certain very specific ways that massively help scalability. In particular, and also it helps what's called the blind signing problem. And so the blind signing problem is something that you've seen in Ethereum, and that's basically, hey, here's a website, it's going to do something for you, so connect your MetaMask to it and sign this contract. And then when you do sign the contract, you really have no idea what that contract's going to do, because it is a fully fledged program that can manipulate the blockchain on your behalf or not, right? But presumably on your behalf because you're signing it. Or so I should say on your authority, right? But it may not be on your behalf or not, depending on whether the website is a fraud or the real thing. So people have gotten a lot of money stolen and also NFTs due to this trick. And so basically, in Nexa smart contracts, they don't have direct access to modifications of the blockchain. What you need to do in your transaction is you put in the beginning, like right at the top, and this is standard for all UTXO blockchains. So again, we're preserving this both for scalability and to become a better financial blockchain. You put at the top, these are the records in the UTXO set, in the ledger, right, that I'm deleting, and these are the records that I'm adding. And no execution of the contract can change those values. All the contract does is decide whether this is okay to do or not okay. And because of that, a wallet can just say right before you click the yes or no button, hey, if you execute this transaction or sign this transaction, it's going to, take this NFT and give it to someone else, right? And then you're like, oh, that's not what was supposed to happen. What was supposed to happen is I was supposed to get like a free airdrop. So this is not something I want to sign, right? So that's the blind signing problem. And then this actually has a huge advantage for scalability as well. And the idea is, hey, you can just execute the smart contract once, okay, at any time. And then when it comes to apply that transaction into the blockchain, you just check whether the inputs that you're deleting still exist. And if they exist, then you know that the transaction can be applied, because the only thing the smart contract can access the blockchain is through those inputs that it declares at the top. And so you simply, if they still exist, then hooray, transaction is good, because I've already checked it. Right. And so why is that like a huge advantage? Well, it's because when a block comes in, we don't have to re-execute all the smart contracts. Right. So all we have to do is check these inputs and then apply, the changes to the UTXO set. It's a huge, huge advantage over all the Ethereum-based, EVM-based, systems, which are more, if you really think about it, they're more a massively distributed, redundant computer that people have put finance on top of.
Right, that makes sense.
Yeah. So, questions about any of that? I know I covered like a huge amount of stuff in like.
Yeah. Right. Well, I think it's important to focus on the difference between a UTXO model and an account-based model like Ethereum. So thank you, Andrew. But I still don't think it's understood in the broader community just how important the UTXO model is for scalability. So Andrew, would you say that like one way to look at it is like Ethereum, there's a huge global state that any transaction can interact with, whereas in Nexa, the state which a transaction can interact with is local. It's limited to those inputs and outputs. Do you think that's a summary?
Yeah, exactly. And so check this out. Let's say you say to yourself, hey, no, I can look at I, as in a program, can be written to look at a contract and figure out what it does, right? Well, first of all, as I'm stating in the white paper I'm writing, that is solving the halting problem, right? And so it's not, theoretically, it's not achievable, okay? Now the question is, would that be achievable in practice? And now let me give you an instance, okay? Let's say I write an Ethereum contract and it doesn't steal your money. It calls another contract. And that other contract is the one that takes your money, right? A contract that exists on the blockchain. See, so if you're analyzing a contract, not only do you have to analyze the contract that's presented to you, but all contracts that contract calls, right? Now, what if that contract calls other contracts provisionally? So now you have to, could call one of 1,000 contracts. So now you have to analyze all 1,000 contracts, right? Okay, and now let me really twist your brains and say, how about I do this? How about I predicate the conditional call of the contract on a piece of data in the blockchain. And when you sign your contract, I quickly, sign a higher fee contract that changes that data. So presumably my transaction will execute first. It'll change the piece of data. So the smart contract that you think you're executing will actually change, right? And then I could go one step further and say, no. That transaction that I raced, that doesn't just change a piece of state that executes an existing contract. that transaction could install a completely new contract just ahead of your execution. So now you somehow have to analyze a contract that doesn't even exist yet on the blockchain. So how are you going to do that? Well, you know, what you really have to do is analyze that the contract doesn't ever call any other contracts relative to a variable, right? And it's just like I'm saying, if someone can attack this system, you could write smart contracts that you know hide their behavior very easily, right? So I think that Ethereum is going to have a very hard time beating the blind signing problem, and the only thing it's going to be able to do ultimately is say something about this contract looks weird. This isn't standard stuff, right? It's doing some weird stuff, and then give you like a question mark. But it'll never be able to say, you know, yeah, this contract is stealing, so don't sign it.
Right. Yeah, that's interesting. Yeah, the complexity of Ethereum is mind blowing. I have another question for you, Andrew. So fundamentally, you know, let's say we had, you know, decades of time to put into Nexa. At the end of the day, what is the fundamental limitations of a UTXO based scripting language compared to what's achievable on Ethereum with the more global state? Like what? There must be some fundamental limits, so things we just won't be able to do with the UTXO that we can do with Ethereum. What do you think those are at the end of the day?
That's a great question, Peter. I actually had a similar one, so thank you for that.
Right. So I find this very interesting because I think what you're actually asking is it possible to write a non-Turing complete program that can validate Turing complete behavior, right? And for sure, that is true in the case where you repetitively, you can call basically your validator in a loop, right? Because remember, ultimately, what a Bitcoin or Nexa transaction, smart contract does is it validates a transaction, right? So, so like the short answer might be nothing really, because you see, because you can write a non-Turing complete smart contract that just validates the operation of another smart contract, right? That's running off chain basically. And so I think the answer might be nothing, but to be more sort of accurate or careful about it, it may be that you've got to break up things that you could do in Ethereum in one contract, in one transaction. You may have to break them up into multiple steps, right?
Right.
I mean,
I think it's an interesting question. I'm not sure anyone's like fully done the academic analysis to really understand what the limitations are.
Right. So let me sketch out like what the proof would look like in terms of, and it's another use of group tokens. So what you basically do is you would say, hey, like every state in the Turing network, right? The network of a Turing machine is a group, right? And every edge is a smart contract that validates whether you can transition from one group to the other, right? And so then you just execute, you can therefore execute any arbitrary Turing machine by in that architecture, right? With that analogy. And
that requires multiple transactions, though.
Yes, it does, and that's why I'm saying.
Yeah.
Right. So the proof, like for me, is sketched out in my head sufficiently so that it works fine with multiple transactions, right? And that's why I was saying you may have to break up your Nexa, your operation in Nexa into a few transactions versus in Ethereum where maybe it can be done in one transaction.
Right. I think that makes sense. Thank you.
That makes total sense. Thank you very much, Andrew. And thank you for the question, Peter. It was a very good timing for that. So yeah, maybe let's get ahead with another question, because we are spending quite a few time on this already. There was a specific question from the community about well, how to say, like, what will Nexa do to bring other layer 2 projects to develop on top of Nexa? And obviously, I'm very aware with the answer, but I think it might be a good moment to give some explanation why that by definition isn't needed. So I'm not sure who wants to answer this. Maybe Paul, you didn't speak so much yet.
Yeah, sure, I can jump in on that.
Sure,
So obviously, because we're aiming for such a high throughput for the network, there is no need for these layer 2 chains in theory. So like the reason why there's been such a big drive on Bitcoin and Ethereum for these layer 2 networks is because they are at capacity, and they have been now for a number of years. So this is because of the when you hit capacity, and even sooner in fact, you drive the fees up, and then because they have much higher transaction fees, everyone's business models start to kind of fall apart, when you're paying like $20 or $50 to send a transaction. And so that drove the need for these layer 2 networks to try and solve some of the cost problems, essentially, and add extra throughput. So Nexa, obviously, once we've actually got all of these technical solutions implemented, then in theory, we'll have this 100,000 transactions per second or higher, and it'll be a long time, I think, until we actually reach that on like a daily basis and hit that capacity. And given that over time technology improves, we'll have even more capacity to offer to people. So I don't think there will ever be a point which will the capacity of the network will be hit once we've installed these technologies. But I think there is a separate need, which is that although Nexa does not need higher transaction throughput, and should get that all natively on chain, I do think there's a need for like interoperability between chains, and I'm amazed I actually managed to say that, because I hate that word. So yeah, because it's not just that other chains have other properties or benefits. It's that other chains have a ton of liquidity and have a ton of projects and users. And so by building a way to connect between the chains, it essentially builds a bridge to kind of pull people over and pull liquidity over to the network and tokens over to Nexa that already exist. So I think this is quite an important problem to solve. And I think we're starting to get the tools necessary to be able to do this. It's something I've spent quite a bit of time looking into at a high level in terms of, okay, what would the smart contracts and model look like to connect with other chains. And one way I've been looking at doing it with Bitcoin Cash, to bridge the two chains, is a technology I call shadow chains. And essentially what it does is it puts the headers of both networks on both networks. So if I explain a bit more clearly what that means. So on Nexa, on the Nexa blockchain, within the transaction cell, within the UTXO set, would be all of the headers from the Nexa blockchain and all the headers of the Bitcoin Cash blockchain. And in theory, the same will be on the Bitcoin Cash blockchain. And okay, I don't want to go into the weeds too much about how you do that, but what the benefit you get from that is that every transaction and smart contract on Nexa, and in theory Bitcoin Cash, will have access to the information in the headers. And obviously the information in the headers is all the transactions that have ever happened on both networks. And so you can do things like perfect atomic transfers from one chain to the other. So you could have a contract on Bitcoin Cash, for example, which says, once you have a smart contract on Bitcoin Cash where you send BCH, or you send a token, and it locks it indefinitely, but it locks it in such a way that there's a smart contract on Nexa which emits, like it produced a new token to match the exact token that was locked on Bitcoin Cash, and that can be then moved around the network as needed, and then it can be sent back to a specific smart contract, which then either locks it or burns it. Probably burns it. It's kind of the same difference, indefinitely, and that unlocks a transaction. It unlocks a smart contract on the Bitcoin Cash side, which releases those assets, and obviously vice versa as well. And by doing so, we then get the benefit of all of the users and the liquidity on the Bitcoin Cash chain, and vice versa as well. So they get Nexa assets as well onto Bitcoin on the Bitcoin Cash networks, and that's a basis for then doing the same with other chains. Now, it only
So,
works
sorry, Paul,
with
is
certain
that working
chains.
right now?
Yeah.
Is this
No, it's
working
not.
right now?
This is not working right now. This is written down in rough format, but I know how to. Yeah, I have a very good idea how to do this, and I'm starting to put it into Nexscript language.
Yeah, sounds awesome.
It's pretty interesting, and I think it will be quite a good model to bridge to other chains as well. Like the key technology to do it, or the key at least opcode, is check data sig, so that you can basically use the signatures from one chain on the other one. But if a network doesn't have that, it becomes more difficult, and there is a way to do it. You have to basically launch a token, either with staking or proof of work. Both are options, where you can basically add an extra consensus mechanism on a token on Nexa, and then that consensus mechanism will basically say, basically what would be done in smart contract form would be done by the miners or stakers on both sides of the chain. So that would be how you bridge any chain. Yeah.
Yeah, that's really cool. So this relies on the block getters being correct in both the parent chains. How are you ensuring that they're correct?
Yeah. So basically, as far as I can tell, the key bits of data are the difficulty adjustment algorithm, because it's predicated on the idea that as long as the smart contract itself is checking the validity of the difficulty adjustment that's happening between blocks, right?
So you could have a false block getter, but then you'd be able to tell it's false.
So the secure we could definitely get into the weeds of how it works here.
Okay,
so basically, the assumption is that you could beat it. You could create fake blocks, but then they're real blocks. So you'd have to use real proof of work to produce them. And so there's a couple of other bits part of it. So it's actually a race between the real blockchain, in this case, let's say the Nexa blockchain, and the shadow chain, Nexa, on the Nexa network. It would be a race against that real one and a fake one. So the fake one could get ahead, but it would have to have 51% of the Bitcoin Cash blockchain to be able to do that. If that's the case, then Bitcoin Cash has got bigger issues than the bridge between Nexa and Bitcoin Cash, right? So I'll send you some information over if you're interested in learning about it. But yeah, that's the best system I've been able to find to build a trustless bridge between the networks that works purely on smart contracts.
Mm-hmm. Yes, that's exciting.
Very cool. Yeah.
Can I jump in there for a second?
Absolutely, Andrew. Go ahead.
Okay. Yeah. So back to the sort of L2 technologies specifically, I just want to mention that as part of the Genesis block features, Nexa has deployed stuff that makes that work. If you wanted to put like L2 Lightning type stuff on Nexa, it actually would be viable and not that hard. Bitcoin has also made changes like SegWit and Taproot to do that, but the original Bitcoin protocol, it wouldn't work, right? And so the key features are the ability to sign a child transaction before you sign a parent. Okay, and the reason why is, think of it like this: what you want to do is enter into some kind of deal with somebody, and so you want them to agree on the exit criteria, how to which sign a transaction that lets you get out of the deal before you sign the deal, which is the parent transaction. So that's a key feature in L2 technologies. And Nexa's has this EDEM transaction ID, and it's not just the boring old hash of the transaction bits. It's the hash of certain selected bits of the transaction, in particular, not the signatures. And the EDEM actually solves this old Bitcoin problem called transaction malleability, and or certain forms of malleability anyway. And then it also will allow you to sign child transactions before parents. So that's pretty interesting. And then also, I mentioned briefly before, these more advanced SIG hash functionality also allows you to do L2 protocols. So just wanted to jump in there and say, hey, in terms of your original question, what cool features does Nexa have? It actually has a bunch of small features in there that make you able to do L2 if you wanted to, fairly easily. And I personally think, I'm not a fan of this worldwide L2, but like if you think in the future of some idea where maybe you're renting bandwidth from a router or something, and it's always like every company wants you to enter into a monthly plan, but no user wants that, because for all they know, they're not going to be back for 6 months, right? So this a higher, like if you just do a point-to-point L2, which we used to call payment channels, that I think remains a very viable use case for L2 technologies.
Right, that makes sense. Thank you for the addition on the question, Andrew.
Yeah.
Appreciate it. So guys, we're running a little bit out of time. I do actually have one important question, and it's also for Andrew, because obviously we're getting this question quite often, given the fact that a few of a fellow colleague UTXO blockchains have these type of measures implemented. So perhaps it's a good moment, Andrew, if you could shine a light on the differences between the how would I call it, the blocks per second and the transactions per second, because one of the questions that frequently pops in is that obviously Nexa has a 2-minute blocks, which is about 120 seconds blocks per second, and I mean, I don't have to mention the name, but there are colleague projects that have a 1 block per second, and we have a lot of questions about it. What is the difference? Why is one better than the other? And maybe you can shine a light on that. I would suggest let's not dive too deep in it, but just a general idea about it, if you could do.
Sure. So first of all, let me just say that obviously if you have 1 block per second, every block has overhead, right? So there's going to be a lot more overhead. So your transaction throughput had better be gigantic to justify that. And secondly, what I think a person needs to ask themselves is 1 block per second doesn't matter. Okay, what matters is what is the likelihood as a function of time that your transaction is going to be committed to the blockchain or disappear, right? And also, what kind of proofs can you offer that your statement is true? Because who are you going to ask, right? If you're a phone, you think that your phone can handle 1 block per second? No, right? Unless you want to have unless you want to drive your telecom provider nuts and get put on a limited data plan, right? So okay, so you have to talk to someone. Who are you gonna ask, right? You have to ask an untrusted node, or if you don't, then basically your app on your phone is just a portal into the real program running on a on a server, right? So don't tell me you have a phone wallet, because you don't. You have a portal from your phone into the real server that has to be trusted. Okay, so let's go ahead and say that somehow you have a phone app. So the question is, as a function of time, what is the likelihood that your transaction can be reversed? And I have not seen any numbers on that. Satoshi in Bitcoin did a derivation, right? What I've seen in a white paper is the proof that it becomes harder to reverse a transaction as time goes on. But I feel like your guarantees will be significantly less. And it's not like on 1 second blocks, you're not going to have the same guarantees as you are on Nexa's 2-minute blocks. And then finally, having said that, Nexa is, planning to deploy a interesting technology that we call Tailstorm. And what it will, what it will do is it basically has miners provide partial proof of work blocks. So, and that basically says, hey, I'm working on this block, but I didn't find a solution yet, right? And by broadcasting those to the network, what wallets will be able to do is watch those partial proof of work blocks and say things like, oh, look, 90% of the network is mining my transaction, and the other 10% appears to not be mining a double spend, right? So, things are looking pretty solid. Or, oh, look, 50% of the network appears to be mining a double spend. So this is a problem, right? I better not, accept this transaction. And so you'll be able to come up with a probabilistic idea of your transaction situation within a few seconds. We're thinking those blocks would come in, in like 5 or 6 seconds on average. So I think that will give people even more. We already have double spend proofs and things, so you can be more certain. And then another thing to think about too is the wallet could be sophisticated enough to say, that's funny. This is really weird because I'm expecting these partial proof of works to happen every 5 seconds, but I haven't received any, enough for, in a 10-second period. So, I'm guessing that some hash power has mysteriously dropped off the network, right? So maybe they're mining a double spend, right? And hidden, right? A hidden mine. Because otherwise, right. And the idea is, well, you're probably not going to leave your mining power dark, right? And then, for months, and then you turn it on to run a double spend. No, you're going to be like mining legitimately on the network. And then if you, attack the system, you're going to take that mining power and try and mine a hidden fork, right?
Right.
And so the statistical analysis might be, sufficient to look at the network and be like, I wouldn't really, I don't love the fact that not enough partial proof of work blocks have been found. There could be a double spend happening. I'm just going to ask, the vendor to hold on for another couple seconds until, a bunch more blocks come in. Partial proof of work blocks. So I think all of this will actually give you a more accurate and assessment of the transactions, and we'll actually be able to come up with hard numbers. And if you think about it, and I find this very interesting, what we're really doing, for those of you who are fans of DAG technologies, what we're doing is we're creating a mini DAG every 2 minutes that then collapses back into a blockchain.
A normal block, right? Yeah.
Yeah. So so I have a feeling that, there's a lot of theoretical work that hasn't been done in terms of comparing, and probably will never be done, honestly. But I think this is an interesting and viable idea, right? And it's sort of like gives you the best of both worlds in that the problem with DAG type protocols is since they can commit conflicts into the blockchain, you can't really rely on SPV proofs. But if you periodically collapse into a blockchain, then you can rely on SPV proofs at that period.
Right. That makes sense.
Yeah. So I kind of like that. We call that tailstorm.
Tailstorm, right? Is there any estimated time for us to implement that? I mean, I know there has been a lot of stuff done right now to write the paper, or I'm not sure if it's finished already actually, but do you have an estimation?
No, so we have a proof of concept done, but that proof of concept had to touch a lot of code. So I've been talking to George just recently via private text on some tricks that we can do to basically massively reduce the amount of changes needed to get the tailstorm functionality with many fewer changes, right? And so I'm feeling more optimistic about the effort because these changes basically boil things down into very few changes to the actual code. So I find that interesting.
Absolutely. All right, thank you, Andrew, for the explanation of that. I think it was very clear, and yeah, pretty excited actually to see a DAG coming to Nexa, because basically that's what it is in the end.
Yeah, it's kind of a very interesting short-lived DAG, right?
Right. Cool. All right, guys. Let me have a quick look in the chat if there has been a specific question we would like to answer for the community. I know we are already a bit over time, but we are with 4 guys today, so we have to respect everybody's speaking time. Give me a quick second. I see. Andrew, maybe you can shine a light on the white paper, because obviously you mentioned it twice today, and we spoke about it privately as well. What is the estimated time for you to release this? Is it something on the short term, or do we think about hours, weeks, or months?
Maybe by the end of the year. I've shared, drafts with people inside Bitcoin Unlimited.
Right.
And yeah, something that people should understand, and I've alluded to this before, is the white paper is not some technical description of, a new technology, because Nexa is intended to be, the best of many technologies. So it would be better to consider it a jumping off point, and then it will cite and refer to sort of more academic level papers like graphene and so forth.
Right, that sounds good. And I mean, eventually we also have the spec.nexa.org for very detailed information about the technology, right? So I think it's a great add-on on what we already have in place. Okay, guys. So yeah, I think that's it for today. Maybe I can shine a little light on the marketing side and the exchange, because obviously a lot of people are also curious to hear about that. So yeah, first of all, obviously, I mean, it's big appreciated from everybody that did a donation recently for the new exchange that we have coming. Unfortunately, right now I cannot mention any name, but big but tomorrow, probably maximum the day after, I will be able to give some clarity about it. Please understand that we, at the point that we make a new agreement with exchanges, that there is always an NDA included, not disclosable agreement. So I mean, obviously, I wish I could share already some specific details, but yeah, due to these agreements, I couldn't yet, guys. So sorry for that. But yeah, once again, much appreciated for everybody that did their part in the donation crowdfunding. Obviously, we are looking for more. We are targeting more. But yeah, that said, again, I hope tomorrow, max the day after, that I will be able to give a good clarity about which exchange we are going to list on next. Personally, I'm pretty excited about it, mainly for the reason that this exchange is quite active in regions that we are not. We have a lot of users from Europe right now, from the US, and obviously also from other regions. But our main users are from these areas. So I'm pretty excited about it. It hopefully will bring a lot of new people within Nexa. Hopefully a lot of developers as well, which I believe is only good for the growth of the project. And secondly, I mean, most of you probably have already seen this. I think we have 5 BWIPs, business improvement proposals open, 5 or 6 in total. I'm not sure by head now. 1, 2, 3, 5 improvement proposals, Bitcoin Unlimited improvement proposals, that are all approved with quite a majority. So I think this is another step forward in the growth of Nexa. I will share the coming days more details about this via Medium articles and on Twitter, what these specific improvement proposals are about. We have, like Paul already said earlier in this calls, about Nexscript for phase 2, Tokenize phase 2. We have a hackathon that we're going to launch early next year, I believe in February. Take it or leave it, let's say. Might change 1 or 2 weeks, but which I think is a very exciting thing, because we have a good strategy written down to attract developers to actually actively participate in this, which comes from a good marketing budget that we received up to the payment and prices that we can provide to these developers. So it's another step in the ecosystem that is already rolling right now. We have a few developers in the community that are building stuff, Shamari, for instance, Otoplo, obviously, and some other guys. And I'm very, very positive about the fact that this hackathon will bring much more eyes on Nexa in terms of users, first of all, but definitely and most important within the developers industry, let's say. So those are a few things on the marketing side. Once again, regarding the exchange, I will share more details hopefully tomorrow, and if not the day after.
Marty, if I may interrupt, jumping with
absolutely, Andrea.
That we I think forgot to mention that could be important for people that want to look at the Nexa technology. One thing is
Sure.
the UTXO commitment, and the other is the quantum resistant signature scheme that we are working on. Actually, Peter Chipper is working on, which called Falcon. These two things,
right?
Yeah, but Peter Rizun could talk further about UTXO commitment, because the thing that the particular incarnation that we are talking about right here is called Cash Drive, and is something that Peter came up with. It is something that could be implemented both in hardware and in software, with the same philosophy as before, that you can have a piece of hardware that you can plug on your normal computer, and your node will be able to handle order of magnitudes more faster the UTXO, which is the amount of unspent transaction output that is the core of any UTXO based chain. And for when it comes to Falcon, the other thing is that we are already working for the moment where the quantum computer would be available to the masses. And this would mean that the normal cryptography that we use right now to sign transaction, which is based on elliptic curves, Schnorr, or the curve that Bitcoin Core is using, would be breakable, like in very short time in comparison to what is available right now. So these are two main themes that people could look for if they are interested to go more deep into the next technology.
Absolutely.
And then to understand better what we are working on.
Yeah, thank you for this addition, Andrea. Well, actually, Peter, maybe you can shine a short light on Cash Drive. I know we are quite a bit over time already, but I think it's a good point Andrea made. So perhaps you can share a bit about it.
I think it might take too long. Maybe we should save it for another show.
All right, yeah, that sounds good by me. Sounds good by me. All right, so yeah, let's wrap it up then, guys. A lot of technology things are coming, which is absolutely great. As you could hear today, all the guys are working extremely hard to deliver new technology to Nexa, to upgrade the technology that we already have. I think for many users to hear that a DAG is coming on Nexa is quite a thing as well. Yeah, I think that's it for today, guys. Please, if anybody has more questions, drop it in the chat or on Twitter, and I will make sure to get it answered either offline or during the next AMA. Yeah, I want to thank you, Paul. Thank you, Peter, Andrea, Andrew, everybody for joining the call, for your time to give an explanation to everybody. And obviously, thank you all community for tuning in. It was, I think, one of the biggest AMAs we had so far. At some point, I saw more than 200 people tuning in, so that's very awesome. Yeah, I don't know, guys. Maybe you have a last thing to say, to share.
It was a
thank
pleasure.
you, Martin. Yeah, it was great. It's great to chat with the community again and with the other guys here. So yeah, like you've said, we've got tons of different things going on at the same time, and there's just a huge amount of work to build up all of this technology and then the ecosystem around it. But we're making good progress on that. So yeah.
Right. Thank you, Paul. Okay, everybody. So yeah, once again, thank you for your time, and we hope to see you again on the next AMA.
Bye, everybody.
Great, thank you, everyone.
Bye.
Thanks,
Bye.
everyone.
Thank you.
Hi.